Hello everyone and welcome to another UNET tutorial. And in this case, the first thing that I need to do is to fix a mistake actually in my position and rotation syncing code. And then after that, I'll show you how to use the network manager, the simulation, using that to simulate latency. Alright, and so it's not an obvious problem, but it sort of becomes more apparent when you start testing the game out on different machines. But my mistake is that I'm doing the interpolation, the lerping, inside fixed update. And that is actually a mistake, because inside fixed update, Time.deltaTime becomes a fixed time step. It doesn't actually vary. It is no longer the time between update frames. It's actually a fixed time step, and we can actually see it. So under Edit Project Settings Player, whoops, wrong one, Edit Project Settings Time, it's right here, fixed time step. So every 0.02 seconds, that is what Time.deltaTime is. And I guess I can show you that as well. If I put debug.log Time.deltaTime.toString, alright, and just run that. So I'll need to build and run, because I'll need a client. Well, a remote client rather. And we'll just, anyway, let's start it over there. Okay, and there you go. You can see in the log console that it's a 0.02. So that is my Time.deltaTime. Now, what's the problem with this? The problem is that on different machines, the lerp rate won't look right. On some machines, it'll look really, the remote players, they'll interpolate to their positions really slowly, and on other machines, they'll move faster because the number of update frames is different across different machines. So that's the problem. So what I need to do is I need to move that into update. So I do need the update function. So let me bring that back. I don't believe I have it anywhere. No, I don't. So void update. Oh, I don't even know I have that line there. Let me get rid of that. Update and put in the brackets here as well. All right. And this is where I should have the lerping happening. Now if I do that and I come, oh, I'll leave that alone. Yep. All right. And rebuild that very quickly. Okay, all right. Okay, so now I can see that Time.deltaTime varies a bit as the frame rates are changing. Oops, and I lost that. Okay, there we go. So it's constantly varying, and the problem, yeah, as I just said, is that way on different machines. Now at least the interpolation will happen at the same speed across different machines, so everyone will see the same sort of thing. Okay, all right, so let's fix that. And that was my mistake there. Maybe I should talk a little bit about that. I guess I probably have already. That this is what you already know, that update frames, they vary. There's the time between them, the space between these bars is the time between frames. You can imagine the bars are frames. So that's how update currently works. And another thing I wanted to tell you about was that the reason for using Time.deltaTime in the first place, because if you do interpolation without Time.deltaTime, interpolation, by the way, the vector3.lerp, I'll explain that too, I probably should, is that it's a fraction from 0 to 1, and each frame, actually I have a slide for that. Oh yeah, there we go, vector3.lerp. And so in this example, I have interpolation fraction of 0.3. And you can have a value from 0 to, well, 0 will mean that you won't get anywhere, to 1. And what that means is that each frame, or each time you run this lerp command, the object, let's say imagine the orange thing is like the player, and the green is where they need to go, then each frame, this player is going to move 0.3 of the total remaining distance towards the target. So if they are at whatever distance, then in frame 2, they'll have moved 1/3, well, not 1/3, 0.3 of the distance towards the target. Then in the frame 3, off the remaining distance, they will move another 0.3 of that distance. Now, one thing that you'll immediately realize, and you will have noticed by using vector3.lerp, is that the distance covered each frame decreases as the object gets closer to the target. And what you see is that the object moves smoothly towards the target, and as they get closer, it slows down to a nice slow, it comes to a nice slow stop. It doesn't just go at one constant speed and then just stop as soon as it hits the target. No, when you use vector3.lerp, it moves towards the target and it slows down, appears to slow down as it reaches the target, because all this interpolation is doing is just affecting the distance between the object and its target position. And that's that's what's going on. So if I didn't use time.deltaTime, and you can try it for yourself, that if I didn't use time.deltaTime, then as I interpolate in the update function, it'll look a little choppy, like not too much, but it will be a bit visible that the amount, this amount distance being covered is not regular. It's not like consistently decreasing. It'll be a bit varying all the time as per the amount of time between the update frames. So when you use time.deltaTime, then you are, I guess, smoothing it all out, because then you're saying time.deltaTime multiplied this fraction, or whatever number. Well, rather, you'll use a bigger number. You won't use like 0.3, you'll use a bigger number. So you can get to a value that's somewhere around 0.3. And because each update is at a different time, it just works out that it'll look smooth. That's about it, really. And then, as I just mentioned just a short while ago, that fixed update, it's a fixed time step. And yeah, so it's not that great for interpolation, and the interpolation speed would be different. Actually, interpolation speed is probably the wrong word. Or is it? No, it's probably about right. I think it's actually okay, because the update, well, it is based off the speed at which update is happening, how many frames we have per second. Okay, so yeah, it's not so good because on different computers, then that interpolation will happen at a different, I guess, will finish at different times, at different speeds. Okay, and the whole thing is that, this interpolation does get a bit tricky in that what you're trying to do, see, the player, when I play the game, and I'm moving around, as you understand, I'm moving as per whatever the script, this first-person controller script, whatever the walk speed is, right? But when I have my remote clients there, they're just dummy remote objects there. Now I'm using interpolation to move them to the positions that are coming from the sync_var variable, and because of that, how do I know that I'm actually moving the client at this speed of, say, 5 meters per second that the original player is moving at? Well, I don't actually, except by trial and error, and if I do some calculations and see how quickly they're getting from point A to B, and I guess figuring it out from there. And that's how I can select determine a reasonably good lerp rate number, or lerp fraction number, really, is what I should have been calling it. And that's how I would determine it. But okay, that's enough of all that, because now we have something else to actually look at, and that is the network simulation. So something that we can do is to actually simulate lag in our game. And let's say, for example, I put in here 150 milliseconds. And this, by the way, is the time taken to talk to the server. And then this same amount of time is required for communication from the server back to the player. So the actual latency is probably like 300 millisecond. And the way it works, it varies it a bit to try and simulate what's happening for real. And packet losses are really like a bad connection, and information that's being transmitted is getting lost. I don't know, let's say if I said 1% loss rate as an example. And then, okay, I go ahead and build and run. Okay, and something to remember is that when I build a game with this network simulation on, then the host, the server, has to be on the standalone copy. Otherwise, it's not going to work out. So I have to put it on here, and then I guess then after that I can connect with here, and it's connected. All right. And let me just move, that's the other player. Alright, so now if I move with this player, you can notice straight away that it does look it looks very laggy. Well, not surprising, because that's what we're, I guess, simulating. Do you know why this is happening? Why that motion looks like that? The motion looks like that. Well, the best I understand it is that because when the message is received for the remote client of where their position is supposed to be, the remote client is going to lerp to that position, right? But because the lag is so much, and it's varying as well a bit, that by the time the next message comes of where the next position is, the remote client's already gone to that place and is now just standing there waiting for the next command. And so because of that, it looks a bit odd. And one thing that shouldn't really be happening is this kind of rubber banding, I guess, effect, or this effect where it looks like they go back a little bit in time. That really shouldn't be happening because the packets are being sent in order. I know that because if I turn on the advanced configuration, I can see that channel 0 is reliable sequence. The reliable, I guess, means that data is only sent if there is a change, and if any packets are lost on the way, then no new packet will be sent until that old one is sent again and it's actually received by the client on the other end. I guess for a game like this, it makes more sense to have like an unreliable, but unreliable eats up more bandwidth. I was reading up on that, and it eats up more bandwidth because it just sends the state information regardless of whether there's been any change or not. So if the player hasn't actually moved or anything, or the values rather haven't changed, then even so, data will still get transmitted, but it doesn't care about whether that packet was ever received or not. If it was lost, too bad, it just sends the next one, and that way the player will keep moving to the latest position that it receives. But I haven't really simulated with a very high packet loss, so I mean, I've tried it out with different things, and it doesn't seem to make that much difference, so I'm just gonna keep to reliable sequenced. And actually, while we're at it, so you can see that there is lag, but we can't actually see what the latency is, so I'd like to expose that. And I'll just turn off that debug.log statement there. I'd like to just expose that. So I might just add, not in this scene, I'm going to add a bit of UI. So in the main scene, rather, I will add in a UI, a text, which I'm going to put the latency in. I'll just call this text. Latency text. I will position it at the lower left and use Alt to set the position as well. Okay, there it is. It's down there. I'll use best fit, and I guess that is it. Okay, and then next thing, I need to go to the script, and I need to access the network client. So I've got here the network client, and of the functions that I need to use to get the latency, I need to use get RTT, which gets the return trip time for this connection. Now, how do I get to the network client component? Well, it's within the network manager. So first of all, I need to access the network manager. So, but I'll just make here a new variable inside player sync position, private. Let me see, network manager? No, network client. I think that's what I should call it now, because that is what I'm after all. And client, I'll just call that. And I I will have a start function as well now, void start, to set up a reference to it. Okay, and I guess let's see, network. So this only needs to happen once, really. So if is, yep, okay, so if is local player, then n client is equal to GameObject.find, and that game object is none other than this network manager, which is now back on the other scene. So coming back, yes, I'll save that. So I'll just get the name because I couldn't remember what I'd written for the name and whether it had spaces or not. So network manager dot get component, and the component is the network. What am I getting anyway? Network manager. Yes, I'm getting the network manager component dot client. Okay, there, I've got it now. Now that I've got the client, I guess I'll make myself another function, and oh, actually, I don't need to do this at all. It's unnecessary. I can do that, but all it means is that every player who is instantiated in our game, even the remote clients, they'll run the start function stuff here. Oh, but actually, I don't care about that, because what I really do care about is void show latency. And this is where I only want our player to be in charge of this. The player with the script is the one that we controlled. So if is local player, okay. Now I will go and get that latency. So I'll add another variable, private, I think a float, latency. Well, I'll soon see if a float is appropriate. Latency is equal to nClient.getRTT, and it's an int. So no, it says there an int, so I need to change that. All right, and so I'll come back here and say int, and save that. All right, next I want to show it in that text box. So I'm going to make another variable here. I'm going to call this one private text. It's a text. Oh, I need to use another namespace here. I need to bring in another one, which is using Unity engine.ui. Now I can access the new stuff, the new GUI stuff. There we go, text. Latency text, and here I'm going to say latency text is equal to GameObject.find, and that was going back to my menu scene. Oh, sorry, not the menu scene, wrong scene, to the main scene. I think I'm going to be permanently confused by this. Okay, and then come back here, latency text dot get component, and it's the text component. All right, and that's enough. All right, yeah, that should do it. All right, so then over here in show latency, so latency text dot text is equal to latency dot toString to convert it to a string. Okay, done. And I think that would, no, obviously I have to call the function now, so that's not enough. So coming back up, where would I show it? Update? Fixed update? Doesn't make a difference. Probably not much. Not for this. Okay, done. Actually, it's better to put it in update, since that's going to be getting updated all the time anyway. All right, now I'll go ahead and build. And I have my network simulation on. All right, and as I said, I have to put this one as the host. If I might as well show you. If I put this one as, oh, see, I told you, I'll always be confused by this. I have to go back to the menu scene. And now, if I start a host here, and then I try to connect, well, it's not going to be able to connect. So yeah, that's it. It's just not going to be able to connect. So I need to do it from here. I need this one as the host, and then this one is the client when I'm doing the network simulation. And now at the bottom left, I can see the latency. and it's very high latency that I'm trying to simulate. And as you can see, it looks well, it looks pretty choppy woppy. I don't know if it'll actually look like that if I played an online game and with a lot of lag. I'm actually not sure if it would actually look like that. I know that in the editor there's already some amount of choppiness in the appearance anyway, so it's probably a little bit of that, and I don't know, maybe perhaps it really would look this bad because it is a server authoritative setup, and doing other stuff like I guess like historical interpolation and extrapolation is, I guess, important. Actually, in the next video, I'll probably show a bit of, I don't know if that's the right name, but a very basic implementation of like historical interpolation, where everyone is seeing the game a bit in the past. And so from that, it looks a bit smoother. It doesn't entirely fix the problem, but it'll look a bit better, a fair bit better. Another thing we can do is to increase the send rate. So I'll do that next. Increasing the send rate does help a bit to smooth things out. Well, just because there's just a lot more, there's more position points coming in for the remote clients to interpolate towards. Okay, now to do that, I need to use this attribute at the top of my script. Network settings, I can say which channel I want the communications, the network communications, to be on by default, and then the send interval. So that's what I want to change. If you look currently inside, for example, the player, so let me just click on the player, you can see that on the sync position, you can see the network channel that's there and the send interval rate as well. And as you know, I already have my, oh, I turned that off, but the advanced configuration there. There's something else I also wanted to show you, which was timeouts. So, for example, if a player is too laggy, like they take way too long to talk to the server will just drop them. They'll just be pushed out. There's no reason. I mean, they're too slow for that connection. It's not like you can even play anyway like that. Alright, so that was just a small thing I just wanted to show. Coming back, oh yeah, that's right. Coming back, what I wanted to do was to put here that attribute, network settings, and what was it called? Let me refer to the script reference here. Well, channel, oh, okay, so channel is equal to 0, and send interval, let's say I put, I'm gonna have 30, approximately 30, well, up to 30 messages, or these, yeah, messages can be sent. So like the sync var itself, when it comes back from the server, up to 30 of these can be sent in a second. So let me try that. So what would that be? Is that 0.033? I think it is. Whatever comes to like 30 approximately, if my maths is okay. I think that sounds about right. Okay. So I'm increasing, and you can actually see, oh, whoops. Yeah, obviously. Need to put in an F, it's a float. That's what the error said, message was there. Okay, coming back here. Okay, so looking at the script now, there we go, it's changed. So I've got a new send interval. So how about I try that? So let me just build that. Okay. All right. So let me run in front. Okay. So it's a little bit better. It is a bit improved. It's still choppy. It's still choppy because what's happening is that basically there's no new data for the player to move towards. That's what's happening, because as you can see, also see the communication time between the server and the client is constantly varying, and that gap is enough such that there's no position, new updated position, there's no latest position data for the remote client object to move towards in my game, and that's why it looks choppy like that. So that's where one trick is to keep like a list of position data and have the player see an earlier position data and then let the remote player move towards the other points in the list, and then by that create the illusion that it's sort of a smooth game experience. Of course, that falls apart when the list starts to get emptied out and it hits 0 with no new entries because of this delay. And the other side of it too is that if the interpolation isn't fast enough, then it's going to be a awkward experience because the player will see other players moving in slower motion, which will also be rather odd as well. So that's just one thing, and I think I will implement that in the next video, a very basic implementation, so you can see at least one method of trying to improve this situation where we have rather jerky motion across the network with high latency. Okay. So let me just quickly change the sync rotation script as well. And this one, I will just move that lerp rotations into the update function. So I'll cut that out right here, void update. All right, done, okay. And another thing to look at is coming back here. Yes, the character controller, as I just wanted to talk about that very briefly. I think a lerp rate is about 15 is about right. It is a bit of trial and error. I do need to like plot some points as the player moves and just determine how quickly they're moving. I do need to do something like that to figure out about that. But anyway, that's another story. All right, so for the character controller, now at the moment, so I'll show you, the players do walk inside of each other because I turn off the character controller. And turning off the character controller is basically meaning they have no collider on that player. So I just thought I should just show you that in case you do want a game where your players can't walk inside of each other. So, for example, if I run up to this player, I can walk right through them, which is great when you have annoying players who like standing in doorways. But if you don't have that kind of problem and you do want the player to have a collider, then you do want to turn on the character controller. And also if you wanted to do hit detection using the character controller. So I will very quickly change that. I will now turn it on. I'll go back to the script, the network setup script, and I will just comment that out. Yep. Okay. So now that I've commented that out, I will build and run again. Okay. Jump in. All right, and I shouldn't be able to, yep, I can't walk inside of them. I can jump on top of them. Yeah, okay. All right, it's all good. That's all good. Okay, so I think that's enough for this video before it starts ballooning out and becoming way too long. I guess in the next video, that's where I'll show you about what I was talking about, keeping a list of positions and then having the remote client move to positions that were slightly in the past to try and smooth out the motion so that it doesn't hit a point where there's no new data for the remote client to move to. And so by that happening, you have the very I guess jittery motion in the game. All right, thank you for watching, and I hope you benefited.